Motion is fun. There are all sorts of ways you can have motion. Here we are going to graph two kinds of motion, because making graphs means you are cool. I drew this little picture here. Yeah, it's kind of bad, but yeah. So there you go. Two kinds of motion. Let's begin.
So the x-axis is the distance, and the y-axis would be the time. Now, what does the slope tell you? The slope tells you that it is in constant speed at every time.
Now, if the line were to be at a curved angle, I mean the velocity would be changing, so it would either be getting faster or slowing down. But since the line is pretty much a straight line, then you can tell that the velocity is pretty much unchanged, so it's moving at a constant speed at all times. Yeah.
Very constant. Hello. Okay, first before I start, I'm just gonna take care of this little line right here. Okay, so that's taken care of. So, basically, you see how there's this is the y-axis, and this is the x-axis. So basically, as you can see from here, the slope is heading downwards. This means that it is speeding up. And to add on to the fact that it's speeding up, you can see how the dots are getting further away from each other, and basically going all the way down here. So yeah, here's
Yeah, so it goes from the guy's hand up here, which is where the line should be, not down there. That's not where it should be. And you can see the slope of the ball as it leaves his hand, and the little dots represent an increase in speed between each fraction of time. So as time goes on, you can see the speed of the ball increasing until it hits the ground right there.
okay. So there are a number of ways in which these two, the basketball and the yeah. So there's a number of ways in which these two are very, how you could compare them. To begin with, this stays at constant rate. This changes, gets faster. That is one difference. If you want to talk about more practical differences, one's kind of, falling through gravity, one's propelled. But still, though, one is speeding up and the other one is kind of going more or less at the same rate. So that's one thing you definitely have to factor in.
So our hypothesis is human force versus gravity. Now, the human force is this one over here. He is propelling, he's throwing the ball to the hoop. Now, the gravity over here, gravity force, the person is dropping the ball, he's letting it go. So the difference is from him from shooting is going to a constant speed, and dropping is going faster.
So yeah, basically what he just said, in very practical ways. You got a little dude here, he just hucks his ball. It goes up, ball right here, badly drawn ball. So basically, it has this, and there's gravity. This guy, you got this dude way up here. Alright, so he's got his ball right here, and he's just I'm gonna let go of my ball. So then it falls, and gravity just pulled it down because gravity likes to do that. Yeah, I'm gravity. I have a hand. Anyways, so there you go. So gravity force caused it to speed up as it fell. This just kind of maintained at the same rate up through where it got in the hoop. Now, of course, we were also scaling after it fell on the hoop, then it probably would have turned into something more like this. But the fact is, we were only really scaling into the hoop. So, in that way, you know. But for the most part, that is the distinct difference. So we got, I can't write with this. But anyways, you get the idea. So there we go.